Hello friends, whenever there are decimals in the power or the exponents, then the problem looks little bit difficult, but you don't need to fear these type of questions, simplification questions. And paper setters in banking exams, railway exams, whatever exams involving quantitative aptitude, they frame such questions just to test whether you are comfortable with decimals or not. So in this video I am going to take up some questions involving simplifications of decimal powers. As you can see on the board, I have written 4 questions, and here we have 1.5, 0.25 powers, and here also we have 1.8 and negative power, negative decimal power also. So all these simplifications are very easy. You just need to look at the problems with a proper attitude. So let's see the first question. Here we have 16 raised to power 1.5 into 81 raised to power 0.25. If you are able to convert the decimals into fractions, then the problem will look little bit more simpler. I'll show you how. See, this problem is actually 16. Obviously we can factorize 16 into its prime factors, like 2 into 2 into 2 into 2 4 times, and 1.5, 1 and half, is actually 3 upon 2. So you can write it as 3 upon 2, and you will see that the problem will look much simpler. 81 also can be factorized as 3 written 4 times, and 0.25, very easy to convert, right? 25 upon 100, so that is exactly 4 times, so 1 upon 4. Now the problem will look much easier. This is 2 raised to power 4, and we have another exponent 3 upon 2. Then we have 3 raised to power 4, and we have another exponent 1 upon 4. So here we have the 4 getting cancelled, and here also we can cancel the common factor 2. So in this problem we are only left with 2 raised to power 6, and here we have just a 3. So 2 raised to power 6 is 64, and 64 into 3 will give us the answer of this question, that is 192. Let's see the second question now. Here we have a 2 in the base, here also we have a 2 in the base, but in the denominator we have a 4 in the base. So 4 can be factorized, and similar to the first question, we will be converting the decimal exponents into fractions and then factorizing whatever bases we can. So in this problem, in the numerator you can see that both the bases are same and we have a multiply sign in between. So what happens when we have a common base and the two terms are multiplied together? The exponents get added. That is a basic law of exponent. So in the numerator we will have 2 raised to power 1.5 plus 6.5, whereas in the denominator we can factorize this 4. This is 2 square, and what is 3.5? 3 and half. So it lies between 3 and 4. So that is 7 upon 2. So you can write this as a fraction 7 upon 2. So here 2 gets cancelled, and in the numerator we have 2 raised to power 1.5 plus 6.5 is 8, and in the denominator we have 2 raised to power 7. So 2 raised to power 8 minus 7, another law of exponent, which gives us the answer 2. Whenever the bases are same and the two terms are divided, then we have to subtract the powers. Very easy, right? Most of the students who are comfortable with decimals and laws of exponents, they can solve this problem just by looking at the problem. And if it is a multiple choice question, it becomes much more easier. So let's see the third one. Little bit difficult here because we have a larger base. Unlike these numbers, the bases were very small. Here we have 252. So we need to factorize this 252 first in order to see what factors are involved in this base. So I will factorize this 252. This is divisible by 2. So 126. So another 2. So 126 becomes 63. So 3, it becomes 21. Another 3, it becomes 7. and 7. Now this is the art. You have to learn how to make factors of any number orally without actually writing it the traditional way which the students use. And what is 2.5? 2.5 is half of 5, that is 5 upon 2. In the denominator, if we have a term which can be factorized, we will do that. 36. 36 is, okay, I'll write it as 6 square. And we have another exponent 1.5. 1.5 is half of 3. And we have 7. This is 0.5. 0.5 is half of 1. So 1 by 2. Now after this step, things will get easier, because in the next step we may have our answer here. Here 2 is getting cancelled. So in the numerator we have this 2 square, right? So 2 square into the power exponent 5 upon 2 multiplied by, again we have 3 square power 5 upon 2 separated out, and 7 raised to power 5 upon 2. So all the 3 powers I have separated out. And in the denominator I have a 6 raised to power 3 here and 7 raised to power 1 by 2. I'll use them later. So the next step, I'll write it here. So this 2 gets cancelled, here also 2 gets cancelled. So we have 2 raised to power 5 into, here also we have 3 raised to power 5, and here we have, see, two terms which contain the same base 7 and different exponents. So the powers can be subtracted. So 5 by 2 minus 1 by 2. So that is the common power, and in the denominator 6 cube, right? So 6 cube is actually, okay, I'll write the terms in the numerator as it is and subtract 5 by 2 and 1 by 2 is 4 by 2, that is 2. And in the denominator 6 can be factorized as 2 into 3. So we will have 2 cube and a 3 cube. Now you can see 2 cube gets cancelled, leaving power 2 here. 3 cube get cancelled, leaving power 2 here. So your answer will be 4 into 3 square 9 into 7 square 49. So the answer will come if you multiply 49 by 9 fours are 36. You can use the Vedic maths here. 9 into 6 is 54, so 5 carry. Okay, this is 27 and 24. So 27 and 24 is 51 plus 5, 56. Again a 5 carry, so 4 3s are 12 plus 5, 17. So 1764 is the answer of this question. Some more steps I have written because I wanted you to understand in what way we can solve this easily in exam, and in competitions you don't need to write all these steps. Depending on your competency of dealing with calculations, you can leave steps. Let's have one more question. This is question number 4. Now here you can see that we have two different bases which are reciprocals of each other. Here we have 3 by 2 and here we have 2 upon 3. So what happens when we invert, when we take the reciprocal of any base? The power changes sign. So in order to make the base same, what I am doing is I'll keep 3 by 2 power 1 by 8 as it is, and here I will take this as 3 upon 2. I am taking the reciprocal of this so that they can have a common base, right? So minus 1 by 2 will become plus 1 by 2. So this is another law of exponents, that whenever we have a raised to power minus m, that means 1 by a will become power m. So this is the law which I have used here. And divide by 4 by 9, I don't need to do anything with that. Even if you want to convert this into multiply, you can do it. I'll do it later on in the next step. Now let's see the next step here. Now I have a common base with a multiply sign in between. So what happens? The powers get added. So base 3 by 2 and the powers 1.8 and 1.2, they get added. Divide becomes multiply and this becomes reciprocal. So 9 upon 4. So here you have 3 by 2 raised to power 1.8 plus 1.2. It's a round figure, 3. So power 3 into 9 by 4. And after this it is just basic calculation which will give you the answer of this question. So let's see, this is 27 into 9 and in the denominator 8 into 4. So what will be your final answer of the question? This will be 9 7 is 63. So 6 carry, 9 2 is 18 plus 6 24. And in the denominator 8 4 is 32. This is the answer of this question. So you can see friends, decimal powers are not something to be afraid of. You know, the paper setters won't give you any decimal power which cannot be simplified. Either you will use law of exponents to simplify decimal powers, or you will be directly converting any decimal power into its equivalent rational number, and then factorizing the base will solve that problem very easily. So these are the things, you know, you need to be aware of, and correct way of looking at these calculations is very important in getting to the answer of these questions comfortably. In quantitative aptitude, these are very common questions, so this is a must watch video for all aspirants of bank exams, railway exams, NTSC, CAT, CTET, everybody who are preparing for quantitative aptitude portion. You need to be aware of this shortcut, and that's why this video becomes very important. So if you like this video, do share it with all your friends so that even they can feel comfortable with the decimal power simplifications. And don't forget to subscribe the channel for more such useful uploads to come in future also.